today we're taking a look at this, and this is a USB calibration box for active cruise control calibration. This is part of an automotive diagnostic system. The reason that we have it is because the USB ports on the side are somewhat broken. So what we're going to do is take it apart, get those USB ports removed from the board and replace them, but also find out what's inside this thing. Let's do that now. Now this was supplied by a local garage who wanted us to repair it. And we'll repair almost anything given half a chance. Let's see what's inside this. It's interesting it has those four USB ports on the side, but also these Molex-like sockets as well, which are normally for low voltage, high current applications. Let's just take these out, and these as well, I think. You see on the top here, there's this port that looks like a USB plug, but it's actually been turned into a socket. That's a nice custom connector there. They definitely go all the way through. I can see the lid moving now. Let's have a look inside here. Oh, there's not much in there at all, really. It's got these nice chunky Molex connectors there. And what looks like, judging by the coils, some sort of a DC to DC switcher. Presumably a dual switcher, as there are two coils on there. Let's get in closer and take a look at some of the chips on this circuit board. And this is the CY7C65630, and this is a low power USB 2 hub controller. No surprise there really, I guess. Now one of the features lists automotive and industrial grade options, so I'm guessing that that's what this chip is. And let's check out the only other real chip on the circuit board. And this is an LT3501 from Linear Technology, which is a monolithic dual tracking 3A step down switching regulator. So I'm not sure why this has this dual DC to DC converter in it. I wonder whether perhaps that they drive these two sockets here, and that provides power for maybe the devices that are being plugged into USB ports, which I'm guessing is some sort of like a wheel sensor or something like that. Now this bit of equipment, which is effectively a powered USB hub, costs about £700 in the UK. So that's pretty much the most expensive USB hub I've ever seen. Now if we have a look at this connector here, we've got a strange kind of reverse USB plug, but we've also got these pins here. And I'm guessing those pins there, given the kind of the size of them, the fact that one in the middle is raised, I'm guessing they provide the power for these DC to DC converters there. So the raised one is probably a ground, and we can check that easily enough. And these two either side are just paired together for current loading. Let's see if that centre pin is connected to the ground. Yep. And neither of those two are. So the centre pin makes first, and then the power pins subsequently mate. Let's remove this and have a look at these USB ports. Never seen one of these. It's always interesting to see unusual things. I don't think most people would come across these in their day-to-day lives. Nice. Now I've got to decide how to remove these damaged sockets, and I think what I'm going to do is disassemble them as much as I can, and then just pull the pins out of the board with my soldering iron and a bit of solder. So I can see if I can open these up. These are nice looking sockets. Not often you see orange ones. Okay, and I can see they're held in on the side there as well. Well, held in quite well. I wonder if that's also soldered in. Maybe. If I can desolder the outside, this outside bit here. I'll try removing the one on this side. There we go. Excellent. Because I don't want to damage the board on such an expensive bit of equipment. And now, I think I'm just going to cut around it with a pair of cutters. Not absolutely sure how I'm going to attack this yet. Don't know how attached the plastic is to that bit there. So it doesn't matter if we destroy this socket because it's damaged anyway. We don't need to keep it. Do you know, I'm almost tempted just to run a Dremel across that. I'm going to continue cutting. I think Dremel is probably the hardcore approach to this. But I think we can just cut these off. That might be a bit of a better thing to do. Well, that's one bit off. Let's cut the other one off as well. So we have to be nice to this. And then I'm just going to cut the plastic away around these pieces here, because I'm really just left with the contacts. That is my plan. And then they'll be much more easily removed from the board. So all those should be able to come off the back now. Let's see if that works. I should just be able to pull them out. I'm just going to add a little bit of solder to those, which will make them easier to remove. Just gives them more thermal mass. Let's do these ones as well. In fact, we could do all of these, get them ready. Do these ones at the front as well on this side. See if we can take some of these out. Hopefully they'll just pull out. Like that. This is probably double-sided board, so we've got to be careful we don't damage the contacts that these go into. So there we go. Give it a good heat up, let the heat go through the board. And that must be on a big bit of ground plane by the looks of it. I'm going to put a bit more solder on that to get that off. That'll probably be one of the power pins going onto this big bit of copper there. That one does not want to come out. Right, I'll have to attack that afterwards, I think. Probably from the top side. So let's break the rest of this connector apart. Well, it's doing that quite well by itself now. We can probably take these off now. Let's see if we can get those out on that side. Getting nice big bits of metal, so it's going to take a little bit of heat to get those out as well. Let's do this one first. Okay, that is coming out. These are big bits of metal, so they get quite hot. That's that out. Now we've still got these to get out. Well, it's taking quite a lot of heat. Wow. Oh, that took some doing. I had to use a real JBC iron for that one. Let's have a look at these other ones. Get those out. And this pin's also taking quite a lot of heat to get it out. And let's take this bit out as well, I guess. Let's chop these off, if I can get to them. One side off, and the other side off. That looks fairly clean. Let's do the other one. Again, we'll trim that down. Put a bit more solder on that. While I'm here, these ones. And that's that one completely off. And then let's cut this down as well. Oh yes, bits flying everywhere, we like that. See if we can get those out. I think I might destroy more of that plastic first. This one seems a bit more resilient than the other one. But they'll all give in the end. There we go. Get some solder on there. Again, this is purely just to get a higher thermal mass onto the joint. Two ones I'm most worried about damaging are actually the ones that come out the easiest, which is the data plus and the data minus pins. Doesn't want to come out though. There we go. Now we'll do the ones around the front. Sorry for that going out of shot. Let's get those out. Quite a fiddly job, really. Especially these pins at the end here. They really don't want to come up. But if we give them enough heat, they will. There we go. That is all the pins out. Now we just need to take that one off. Again, it's going to be a little bit more fiddly. Problem with power planes this big is that they sink all the heat away from what you're trying to desolder. Once the board warms up a little bit, it does make it a bit easier. It's not looking too bad. Now what am I going to do with these bits? Now hopefully I'll be able to desolder them a little bit easier now. Like that. So we can clear the solder out of those holes now. So we can use the solder sucker. It is getting there. Okay, they look good. Now it's just these end ones. Wonder if the way to do those is attack them from both sides, perhaps. They look clear. try that again. That looks like they're all out. Got a little bit of a hanger on over here. Let's get that desoldered. Give those pads a clean up. That looks pretty good. Let's put the new ports in. Here are our new ports. Same as the other ones, but slightly less orange. And hopefully we can just push those in. We might need to straighten up those clips though. Yeah, we need to straighten those up. Let's do that. Looks like all the pins are going through okay. First row done. That looks good to me. Now we can solder the lumpy bits. And this is what keeps these on the board. So these are quite important for structural strength. One done. Let's put the other one on. Looks okay too. And let's solder the anchor points on first. And now we can do the contacts. I'm just going to tidy up these. And just remove that blob of solder from there. We do want it to sit down correctly in the housing. Getting a great lot of copper. Give it a clean. Just a little bit of isopropyl. Just gets rid of any residual flux from the solder. That looks much better. Well, not broken anyway. Okay, now to put it all back together, which will definitely be the easiest part of this job. That's it done. If you enjoyed me repairing what is arguably the world's most expensive USB hub, please like and subscribe. Thank you for watching this video. Bye bye.